Alright guys, welcome to the first notes video for trigonometry. Hopefully you had a chance to watch a little overview video, and this should hopefully clear things up and make some connections from what you saw there to how we're actually going to apply this to solve problems. So first step, what is trigonometry? What are we going to be studying here in chapter 12? And trigonometry is the study of the relationships between the sides and angles of a triangle. So essentially, if you know a few things about a triangle, usually you can find out every other side length and angle measure in the triangle using trigonometry. So that's kind of the point. You'll see as we do problems, if you know a few things, you'll be able to figure out everything else. If you knew all the side lengths of a triangle, you'd be able to find all the angle measures and other things like that. So the first thing is when you're setting up trig ratios, you use the particular side lengths but relative to a given angle. So in this problem here, I put a theta. This is a Greek letter. It's a variable that we use to represent unknown angle measures in triangles when we're doing trigonometry. So if I'm using this as my angle, then what are the sides of this triangle relative to that angle? Now, first one and the obvious one is the hypotenuse. And in a right triangle, the hypotenuse is always across from the right angle. So this will never change. It doesn't matter if you're dealing with this acute angle or this acute angle. This will always be the hypotenuse. Next, if this is the angle I'm dealing with, then this leg across from that angle or opposite that angle, we're going to call the opposite leg. And then the leg that touches that angle, we call the adjacent leg. So because this is the angle that I'm referring to, this is the opposite leg, this is the adjacent leg. Now, suppose that this example looked a little different, and this were the angle that I was referring to. Well, if that was the case, then this leg would be opposite, and this one would be adjacent. But that's not the example we have right now, but that could be the case. So again, the point I'm trying to make is it really is relative to whatever acute angle you're dealing with. Now you may remember from the previous video when I showed you kind of where that stuff comes from and how you can derive these trig ratios by simply dividing side lengths, but sine was the opposite leg divided by the hypotenuse. And cosine was the adjacent leg divided by the hypotenuse. And tangent was the opposite leg divided by the adjacent leg. Now, you may ask yourself, well, how the heck am I supposed to remember that, Mr. Donaldson? And people have been asking that question for as long as trigonometry has existed. And this acronym or little mnemonic device is here to help you. SOHCAHTOA. SOHCAHTOA means nothing aside from a mnemonic device or an acronym that helps you remember that sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the very first thing that you should do in any assessment that we're doing here throughout the unit is at the top of your paper, I always write SOHCAHTOA. And then when I look at a problem that has, hey, what's the sine of this? I'm like, oh, sine is opposite over hypotenuse, and it's easy enough. So let's look at how we'd apply that. So the first type of question I'd ask you, I'd just give you some triangle, and I have some variable here, some unknown angle measure, theta, and then I have some unknown side lengths, A, B, and C. So the first step to this is being like, okay, well, if this is the angle I'm dealing with, what are these different sides? Well, obviously the side here across from the right angle is the hypotenuse. And then there are the two legs. The leg that's opposite this angle that's given is the opposite leg. And the leg that is adjacent to it or touching it is the adjacent leg. So the first question says, what is the sine of theta? Well, using SOHCAHTOA to help remind me what sine means, sine is opposite over hypotenuse. So here's my triangle. Sine of theta, opposite over hypotenuse, is A over C. All right, then cosine of theta. All right, and again using SOHCAHTOA, cosine is adjacent over hypotenuse. So here's theta. This is the adjacent leg. This is the hypotenuse. So adjacent over hypotenuse is B over C. And then lastly, the tangent of theta, and tangent is opposite over adjacent. So opposite leg was A, the adjacent leg was B, so the tangent of theta is A over B. So there you go. That's the first type of question I'd ask, is just in very general, hey, what is the sine, cosine, or tangent? for some angle in a triangle. All right. Next, in order for us to solve problems using this stuff, you got to be able to determine what these ratios are. And I showed you in that other video that, I think I used a 40-degree angle measure for that first triangle. I was like, hey, what's the sine of 40 degrees and the cosine of 40 degrees? And I showed you the trig table and the calculator, and it knew all that stuff. So you got to be able to either use a calculator or a trig table to do this. So it doesn't matter which one you want to use. So let's just kind of do some examples with both. So first, I'll do it using the calculator. Now, the very first thing you got to do if you're going to use your calculator is you must ensure your calculator is in degree mode. Now, if you have a graphing calculator, to do that, you go to mode, and you make sure degree is highlighted. Now, if you have other types of calculators, one way you can test and make sure your calculator is in the right mode is that the sine of 30 degrees should equal 0.5. So when you type in the sine of 30, you just got to find the little sine button on whatever calculator you have, wherever it is. If you're not getting 0.5, then you are in the wrong mode, and you have to change it to degree mode. You could either Google it and see how you change your calculator's mode. You could try to FaceTime me, or go to the Google Hangout or email me, and I'll help you out. So first, what is the sine of 45 degrees? So all I'm going to do is hit the sine button, type in 45, and I get 0.7071. And usually we want to round this to 4 decimals, and that's what 10 thousandths is. All right. So I'm going to round it to 4 decimals, which is 0.7071. All right, and the cosine of 73 degrees. So let's say, all right, what's the cosine of 73 degrees? 0.2924. And what's the tangent of 12 degrees? You just take your calculator, type in tangent 12 degrees. 0.2126. Now, check this out. Suppose the calculator maybe is not what you want to use and you want to use the trig table. Well, we could totally do that. Let me pull up my trig table here. I have one somewhere. And hopefully that pops up here in a second. All right, so here's my trig table. Let's look at let's just go maybe to the second one here, which is the cosine of 73 degrees. So in this first column, you got your degrees, it runs down, and it starts back over and goes all the way up to 89 degrees. All right, so I want to know the cosine of 73 degrees. So I'm going to find 73 degrees here on my table, and in the first column after the degree is sine and then cosine. So I'm going to go, okay, 73 degrees, the cosine is 0.2924. And that's exactly what my calculator knew. So the calculator has this table essentially programmed in it. The tangent of 12 degrees. All right, so let's look. We go down to 12 degrees. Tangent is the third column over, 0.2126. And that's exactly what my calculator has. So it doesn't matter to me. You can use the calculator. You can use the table when solving these problems. But make sure you round to 4 decimal places, or the nearest 10 thousandths place. All right, so here's how you solve these equations. All right. So eventually I'll show you how you set these up, but for now let's just solve them. So this equation says the tangent of 43 is equal to 10 divided by x. Well, the very first step is to determine what the heck is the tangent of 43. And it doesn't matter to me, like I said. You can use the table or the calculator. So maybe for this first one we use our table. We'll go down and find 43 degrees. Well, zoom it back in so I can see it. Tangent was the third column after the angle measure. So there's 43 degrees. And the tangent of 43 degrees is 0.9325. 0.9325 is equal to 10 over x. Just to show you it doesn't matter, I could have done this in my calculator as well. 0.9325, and I'd round to 4 decimals. All right, then the next step. For now, I'm just going to show you the one thing you could always do is you could put this over 1 and then you can cross multiply. And if you do that, you would end up with 0.9325x is equal to 10. And then you would divide both sides by 0.9325. So x is simply 10 divided by 0.9325, which is around 10.7. Or it says to round your answer to nearest hundredth, so we'll say 10.72. Now, you guys, I'm going to show you a little shortcut that will allow you to, avoid putting it over 1 and cross multiplying and all that. All right, check this out. We know that 4 is 12 divided by 3. And we also know that 3 is 12 divided by 4. So one little shortcut you could do is you are allowed to, if you have an integer equal a fraction, you can simply swap these guys, and this is exactly what we get. And so what I'm telling you here is when the variable's in the bottom, all you got to do is just swap these, and that's exactly a shortcut I could do to go straight here. So rather than saying, hey, the tangent of 43 is 10 over x, I could say x is equal to 10 divided by the tangent of 43. So there you have it. All right. In the second case, the variable's on the bottom. So what we're going to do is we're simply going to multiply both sides by 7. And you're going to get 7 times the cosine of 87 is equal to x. So I could just type that in my calculator and say 7 times the cosine of 87, and I can get that x would be 0.37. But if you wanted to use the table, which you most certainly can, you would simply say 7 times, and we're just going to figure out what is the cosine of 87, and the cosine of 87 is 0.0523. And if we multiply those together, we're going to get the exact same answer, of course. 7 times 0.0523. Oops. 0.0523. And I get, again, 0.3661 or 0.37. So it doesn't matter. You can use the calculator, or, of course, you can use the table. All right. Next, we're going to use one trigonometric ratio to find the others. Now remember, trig ratios are defined by right triangles. So the first step to this process, if I ask you to do something like this, is to simply draw a right triangle. There's a right triangle. It doesn't matter how it looks. All right, then you're going to put, of course this is a right angle, then you're going to put theta into one of the acute angles. It doesn't matter. Let's call this one theta. Now, again, so, ka, toa. I know that tangent is opposite over adjacent. So relative to this angle theta, this is my opposite leg, because it's opposite it. This is my adjacent leg. It's the leg that touches it. And this is my hypotenuse. Well, if tangent is opposite over adjacent, that's what TOA tells me, opposite over adjacent, and I know that the tangent of theta, opposite over adjacent, is 8 over 15, well then the opposite must be 8 and the adjacent must be 15. But in order to find sine and cosine, which both of those need the hypotenuse, I first need to find the hypotenuse. And the way I'm going to do that is by using the Pythagorean theorem. So I would say 8 squared plus 15 squared equals c squared, and I would solve for c. But you guys all know your Pythagorean triples like bosses, and we know that 8, 15, 17 is a Pythagorean triple. So I'm not going to do the word. And that hypotenuse must be 17. So now here we go. What is the sine of theta? Well, sine is opposite over hypotenuse, so it's 8 over 17. What is the cosine of theta? Well, cosine is adjacent over hypotenuse, which is 15 over 17. There we have it.